Application of analytical chemistry on the analysis of heavy metal uptake of plants. Heavy metals such as lead, mercury, and arsenic are among the contaminants of our environment. Sources of heavy metal pollution include the expanding agricultural and metal industries, inappropriate waste disposal, and use of fertilizers and pesticides. Heavy metals, although found in nature, become harmful and toxic when these are bioaccumulated in living organisms, which causes biological and physiological complications. Humans are exposed through ingestion of contaminated food and water, inhalation, and thermal contact. Effects on human health include neurodevelopmental effects, poisoning, cell damage, internal organ damage, and carcinogenesis. Additionally, heavy metals can also impose toxic effects in plants, although some tolerant plants have developed mechanisms that are activated upon exposure. At this point, analytical chemistry comes into the discussion. Several techniques to assess the presence and concentrations of heavy metals in soil, water, and plants involve analytical methods.
Atomic absorption spectroscopy is a commonly employed method wherein the spectrometer is calibrated to a wavelength for the respective heavy metal being tested. Based on the amount of light absorbed, presence of a particular element in the material can be determined by matching it with known standard. Consequently, the concentration of the element in the sample can be calculated using Beer-Lambert's law based on the generated calibration curve and the equation of the light. Aside from AAS, flame emission spectroscopy and UVV spectroscopy can also be used. However, AAS is preferred due to its better precision and accuracy, low cost and rapid instrumentation, and capability to analyze over 62 different metals in a solution. Going back to the heavy metal tolerant plants or hyperaccumulator plants, these are used in phytoremediation techniques which utilize the distinct and selective uptake capabilities of the plants. Of course, AAS is also applied to determine the presence and concentrations of heavy metals absorbed by the plants.
Some related studies which implemented AAS are the following. Application of Aztec marigold for phytoremediation of heavy metal polluted lateritic soil. Heavy metal uptake by plants from wastewater of different pulp concentrations and contaminated soils. And phytostabilization, a management strategy for stabilizing trace elements in contaminated soils. With the help of the application of analytical chemistry, problem on heavy metal pollution can be eradicated. Indeed, analytical chemistry is not just a mere field of study, but it plays an important role in addressing problems of humanity. And this concludes our presentation on the application of analytical chemistry on the analysis of heavy metal uptake of plants. Thank you!